Module 2, Lesson 6, the periodic table. So as you know, the periodic table is more than a reference sheet. It is a list of all the known elements in the universe, and it also is an extremely useful tool in chemistry. The elements on the table are organized by their atomic number. So, if you remember, in the top left-hand corner of our periodic tables, you'll see the number 1, 2, 3, etc. This pattern goes across the table from starting in each row, and the pattern continues all the way down. Now, if you haven't done so, please take out your periodic table so you can follow along with this lesson. A quick recall, the atomic number is the number of protons in the element. So here we see oxygen, top left, atomic 8, means there are 8 protons in oxygen. The protons provide the identity of the element, just like a fingerprint would for a human. Rows and columns. The table is divided into rows, which we call periods, and to columns, which we call groups or families. The horizontal rows are called periods and are labeled from 1 to 7. So here's a picture of a periodic table, and the rows go across from left to right. So on this picture, they've all been color-coded. Now, when we get up to row 6 here, you'll notice that there's 2 colors that are the same, here and down here. This row actually slides up into the periodic table where the space is. Same with row 7. The colors match, and they both slide up into that empty space there. However, if we had a periodic table with those series in there, it would be way too long to fit on one piece of a paper. Now, what's important about the rows of the periodic table? Well, they all have the same number of electron orbitals. That's one connection. So, both elements in row 1 here have 1 orbital or 1 shell. All the elements in row 2, all the way across, have 2 orbitals or 2 shells, etc. To take a bit of a closer look at it, we just discussed that the shell numbers go along with the numbers here. And one other little handy thing to look at, and you have this on your periodic table as well, is the electron configuration. So you'll note it's in the bottom left-hand corner of each of the symbols. So here we have hydrogen, there's a 1, lithium, 2-1, sodium, 2-8-1, etc. So let's take a look at how this looks. Hydrogen up here, for example, has 1 in the left, which means 1 electron in its first shell. Now, if we go here to magnesium, 2-8-2 means there's 2 electrons in the first shell, 8 in the second, 2 in the last. Here's a Bohr-Rutherford diagram. 2 in the first shell, 8 in the second, and then 2 in the outer. So you'll find this electron configuration to be quite handy. Okay, the vertical columns are called groups or families and are labeled from 1 to 18. Now you'll notice it says most of the time. This is a newer way of labeling the columns, so you may see other numbering or lettering involved, but 1 to 18 is pretty standard now. The columns are grouped into families. And if we look below, we're going to be looking more so at the colored groups for this course. And again, the groups follow the color pattern down. Now, what I want you to do is take a look at your periodic table. Using that electron configuration in the bottom left-hand corner, take a look at the valence electrons in all of the family 1 or column 1 here. What's that last number? Now go and take a look at number 2 using the electron configuration. What's the last number? Seeing a pattern? Check out 13, 14, check out all those families and see what the last number is as you go down a group. Chances are, if you did that, you'd notice that the valence electrons are the same in each family. Did you also notice that group 1 had 1 valence, group 2, 2 valence, group 13, 3, 14, 4? So how many would there be in 17? Without looking, you can probably guess there'd be 7 valence electrons. Great. So you've just discovered 2 very important trends that are seen on the periodic table. Now, we'll take a quick look at the families or groups of the table. Alkali metals. Note, there's no hydrogen in this group because hydrogen, if you recall, is a nonmetal. So all the other elements in group 1 are alkali metals. They have 1 electron in their valence shell. Very, very reactive. They're not freely found in nature due to this reactivity. Malleable, ductile, and conductive. And these metals are softer than most other metals. Alkaline earth metals, group 2. Metallic elements again. 2 electrons in their valence shell, very reactive, not as reactive as column 1, but still quite reactive. Malleable, conductive elements. Just to go back to that reactivity, they again are not found in nature freely. Transition metals. That's that big group in the middle. There's 38 of these elements. Again, malleable, ductile, and conductive. What's neat about the transition metals is that their valence electrons, so to speak, don't appear just in the outer shell. They actually bond with other elements with inner shells as well. The inner shells can actually hold up to 32 electrons, so it allows for a bit more of flexibility when they bond with other elements. Boron family, group 13. 3 electrons in their outer shell. Most of them are metals. Boron is a metalloid. Carbon family, group 14. 4 electrons in their outer shell. Contains metals, metalloids, and 1 nonmetal, which happens to be carbon. Nitrogen family, you guessed it, group 15. 5 electrons in the outer shell. They can share electrons to form compounds. They contain metals, metalloids, and nonmetals. And there they are there, group 15. Oxygen family, group 16. 6 electrons in the outer shell. They contain metalloids and nonmetals, reactive. Halogens, group 17. 7 electrons, all metals, all non-metals, very reactive. Noble gases, group 18. Now, ironically, these guys aren't reactive. They exist as gases. They're all nonmetals. And they're non-reactive due to this property right here. They all have, if you take a look, 8 electrons in their outer shell. They have a full octet. That means they're stable. They're not bonding with anything. And we'll take a greater look at that in the next lesson. Now, helium, you may have noticed, only has 2 valence electrons, or 2 outer electrons. And this also is considered full, because think about that first shell. It's full after 2 electrons, and then you move to the next one. Okay, and as I mentioned, does not react with other elements because their outer shell is full. Rare earth metals you will find at the very bottom of the periodic table here, the ones that actually fit up here. You have 2 series, the lanthanide series, which runs from atomic number 57 through to 71, and then the actinide series, which runs from element 89 to 103. Some are radioactive. The rare earth metals are silvery white or gray metals. They conduct electricity. And that is the end of this PowerPoint presentation. So thank you for watching, and I'll talk to you later.